The future's so bright.
The future's so bright, we gotta wear shades. And then we just do this.
That'd be perfect.
All right, we don't want to do this? All right, we'll do this.
It's like a Men in Black thing. Then it's like the aliens coming.
Yeah, no, that's fine.
No, we could do that.
We'll let's stick with the coffee cup. It's our signature.
It's our signature move.
A signature. I'm going to start that over.
Take time.
Let's take a break. Okay. Good evening, and welcome to the Autism Blogcast Special Report. I'm Jim Mancini.
And I'm Rafe Bernier. We've made major advances into the genetics of autism since my old mentor, Dr. Susan Folstein, conducted the first twin study of autism back in 1977. At the time, what she was able to do is demonstrate that autism has a strong genetic component. Now, since then, we've had major advances in our technology that have allowed us to identify hundreds of genes and genomic regions that are implicated in autism.
So that means we'll be able to identify changes or differences that are part of our DNA.
Exactly right, and we've identified already several hundred that we believe are associated with autism. But really, it's been families that have been at the core that have allowed us to do all this work.
Well, you know, Rafe, families have been influencing autism research for a long time.
Well, for sure. I think about that the original twin study. It was back in the 60s and 70s when parents said, autism isn't caused by cold, aloof parenting. It's actually caused by a biology. There's a biological basis to autism. And that's what really drove some of those early twin studies.
So what does involvement in autism genetics research look like?
Well, it involves, I guess, blood, sweat, and tears from families, really, and maybe sometimes all three of those things. What participation involves is usually a visit to a clinic, and at that clinic where expert clinicians will spend a lot of time with families conducting neuropsychological testing, maybe a dysmorphology exam, a medical exam, perhaps an MRI and EEG, and then finally a DNA collection via blood or, more recently, via saliva.
So basically, it's a lot like a visit to the clinic, except for the spitting.
Right. Clinic visit plus spit. Exactly. And so with all this participation, what we've been able to do is identify a number of genes that have reached statistical significance for an association with autism. And we've done that by assembling large cohorts of individuals who have a diagnosis of autism, and then we scan through and look for genetic commonalities among all of these individuals with autism. And that's the way we used to do things for a long time. We've now taken a new approach, which is called genetics first approach, instead where we identify individuals who have a similar genetic background, a significant genetic event, and then identify all the individuals with that same genetic event and try to figure out what the profile is for those families.
Wow, Rafe, that was a lot of words. Did you guys understand that? If not, let me try to explain a little bit. Scientists have identified a bunch of genes that seem to have something to do with autism. And for a long time, what we did was we took groups of people with autism and tried to identify some genetic commonalities within those groups. What we're doing now is looking at huge groups of people, and then when we find something that is a little different or interesting, we follow up with those individuals. What's interesting about this is that when we pay attention to the unique characteristics that are related to this specific genetic profile, we're able to use this information and we're able to find out and understand the importance of that specific gene.
Exactly.
Okay? So what we're going to do with this information is take it into the clinic eventually, where we'll be able to develop some evidence-based practices and plan treatments that are going to be relevant for these individual groups.
Exactly.
And then what's really great about it is that we're able to share this information with families so that they can therefore share their information together and provide support for each other.
Exactly, and that's the immediate benefit of this approach, is that we can link families together so they can suddenly have a nice common framework for discussing the challenges their children have, while at the same time scientists are working towards thinking about those targeted treatments that are specific to that given individual's genetic background.
What's great, Rafe, is that we have a parent here who's going to be able to tell us a little bit about her perspectives. Today we have Jen DeBona, mother of 8-year-old Miles, here to talk to us a little bit about autism research. Jen, first of all, did you understand anything Rafe said?
No, after his introduction, it flatlined for me.
Well, you know, I am a speech-language pathologist, so helping people communicate and understand communication is kind of what I do, especially for guys like Rafe.
Good. We're going to need you.
Yeah. My other question is, what do studies into the genetics of autism mean for your family?
Well, I think for my family and a lot of families out there that do have children with special needs, what you're studying now in genetics is so important, because had we had that information when we were starting our family and already had 2 older stepsons, we would have been able to prepare a little bit differently for what it was lying forward. Usually parents will save up for vacations and camps and then college. But what you do with a special needs child is you have to go even further than that and plan for a lifetime. So retirement does look a lot different. And so for some families, that's not feasible or an option.
Right. So this type of research is really relevant for your family.
I think so. Absolutely.
So what do you think scientists should be studying?
Well, if I had my choice of what scientists would do, I would love if they were able to even drill down a little bit further. Maybe something where they could even find a marker that would even let you know where in the spectrum your child would be. Is your child going to be verbal? Is your child going to be low functioning, high functioning? And just that way you can prepare a little bit better and get your team together before your child's even brought into this world. So those wait lists that are a year to 2 long to get the diagnosis can maybe be shortened a little bit by starting earlier.
So thanks so much, Jen, for joining us today. Jen DeBona, an amazing and smart advocate for families with autism. We'll be right back.
Well, Jim, it was really great to have Jen on the show here today to talk with us a little bit about what parents really want to see happen in terms of autism genetics research. It's a nice opportunity for scientists to hear, well, this is kind of what parents are looking for.
Mm-hmm. And so much excitement in regards to advancements in autism research and genetics. Lots good to look forward to.
I agree. Well, that's it for this special report. Just keep watching.